Hello, physics students. I am Mr. Williams. Today we're going to be continuing practicing the kinetic energy equation and using directions. Determine the kinetic energy, mass, and speed of each scenario. Show units, equations, and calculations. Remember, KE equals 1/2 mv squared. So I'm going to do practice exercises 1 through 5, and you are going to be responsible for doing 6 through 10. Okay, so make sure you are good at using this equation. As you are watching this, you need to have pencil and paper in hand, and you need to be writing this down as I do this. You are not going to learn this if you treat this like a television show and passively watch it. Be active. All right, for number 1, write the kinetic energy equation in the box below. Identify what each variable represents. Okay, so we got KE equals 1/2 times m times v squared. Yep, just like they said over here. All right, the kinetic energy represents, KE represents the object's kinetic energy. Okay, m represents the object's mass. V represents the object's speed or velocity. Remember, velocity is the same thing as speed, but velocity has a direction. 2, a jogger whose mass is 60 kilograms is moving at a speed of 4 meters per second. What is the jogger's kinetic energy? Well, we don't know what the kinetic energy is, so I'm going to put a question mark for that because that's the unknown. The mass is 60 kilograms, and then they give us a speed of 4 meters per second. I like to write the kinetic energy equation each time that I'm going to use it. Then I write it again right below it, except this time I substitute the values that we have. So we have 1/2 times 60 kilograms times our v squared, in which we have 4 meters per second. We're squaring that. And so if we put that into a calculator, we know that 1/2 of 60 is 30. And then 4 squared, which same thing as 4 by 4, is going to be 16. And then we do 30 by 16 in our calculator. Put that in the calculator real fast. Okay, let's use the on-screen calculator so you can see what I'm doing here. So we have, move that out of the way. So we have 30 times 16. All right, and we got 480. Okay, so that's going to equal 480 joules. All right, so it's a good idea to put a box around your final answer. Help your teacher find it, and teachers are less likely to make mistakes when grading, right? All right, a little better box around there so it doesn't cover up our next problem. Okay, scrolling down. An object has a kinetic energy of 25 joules and a mass of 10 kilograms. How fast is the object moving? Well, the kinetic energy is something that we are trying to calculate. No, take that back. Kinetic energy is 25 joules. Okay, that's what it says in the problem. The mass is 10 kilograms. And it asks how fast is the object moving, so that means that's something that we're going to have to calculate. So we got a question mark for our speed. I'm going to rewrite the equation here. This is going to require us to do a little bit of rearranging the equation. We just can't multiply the numbers together. So I'm going to plug in the things that we do know. Switch to blue here. 1/2 times 10 is our mass. And then v squared. And we actually know our kinetic energy, so I'm going to erase that. And then I'm going to put 25 5 joules. So I'm going to simplify this by multiplying the 1/2 times 10. So we'll end up having 25 joules equals 5 kilograms times our V squared. All right, so we can just divide both sides by 5, and what we'll end up with, divide both sides by 5, and what we'll end up with is, we'll have 5 equals V squared, okay? And so what we need to do is to get rid of that V squared, what you have to do is take the square root of both sides, okay? And so what we'll end up with here is V equals, and let's see what square root of 5 is. So it's not going to be a clean number. So 5 square root, it looks like square root of 5 is going to be about 2.2. All right, so we're just going to do 2.2 for that value. 2.2, and so that's going to be meters per second, and that's our answer. Okay, do number 4. A diver had the kinetic energy of 12,000 joules before hitting the water. If the diver's mass is 40 kilograms, what is his speed? So in this example, they gave us kinetic energy of 12,000 joules, and the mass is 40 kilograms. And so we're doing another example problem, like one above, where we're calculating for velocity, right? So we have our kinetic energy equals 1/2 times mass times v squared. Okay, then I'm going to start plugging in what we have. So we have 12,000 equals 1/2 times 40 times our v squared. Let's simplify. 1/2 times 40 is 20. Becomes v squared. 12,000 over here. And what we're going to need to do to get that 20 to the other side, since it's multiplying, we need to do the opposite, and that's divide both sides by, I don't know why I wrote that number. Let's divide both sides by 20. All right. So we divide both sides by 20. All right. And so what we're going to get when we do that is we will have, all right, 12,000 divided by 20 is going to be 600 equals b squared. And so we need to take the square root of both sides. All right. We'll take square root of both sides. And then the square root of 600. Okay. Is going to be 24.5. I think so. Wait, is that what it was? Yeah, 24.5. It's an ugly number. We'll run around. So we can say that 24.5 meters per second is our speed. Okay, that's how you do that. Did 2 of those. So you should know how to do that. All right, number 5. A roller coaster car with a kinetic energy of 25,000 joules has a speed of 10 meters per second. What is the mass? So this time we're determining the mass. We don't know what the mass is, so we're going to put a question mark there. The kinetic energy of the car is going to be 25,000 joules, and the speed is going to be 10 meters per second. We're going to rewrite the kinetic energy equation. Kinetic energy equals 1/2 m times v squared. Now we're going to start substituting those numbers. So kinetic energy is 25,000. Okay. And then our mass we don't know, so we'll just put mass right there. And then times our speed, which is going to be 10 meters per second. That's something we got to square there. Okay. Don't forget about squaring it. So what we need to do, well, you have to do your exponents first. So as we rewrite this equation, we're going to have 1/2 times m times 10 times 10 is 100. All right, and we'll have our 25,000 joules right there. All right, so 1/2 times 100, looking at the right side, that'll give us 50. And so we can rewrite the equation as 25,000 is equal to 50 m. And now to get that to the other side, we're going to divide both sides by 50. Okay, this will just be m on that side. And on the left side, what we're going to have is 25,000 divided by 50. I have a big O number of 500. All right. Okay, and we're talking about a mass. So we have it in kilograms. All right, guys. So that is 4 example problems on how to do the kinetic energy equation. After this, you are going to be using these 5 questions, number 6, 7, 8, 9, and 10. All right, guys, you can do this. Keep practicing. Make sure to ask questions. Be specific about what it is you know and you don't know. All right, you got this.